Hello friends, I hope everyone is doing great. Today in this tutorial, we will continue our lessons on basic statistics. So in today's class, we will cover these following topics. What are random variables? What is the definition of statistics? And the other ones as well. So in the last tutorial, we discussed about measure of central tendencies. We discussed about measure of dispersions, wherein we studied about mean, median, mode, variance, standard deviation. We also looked at what exactly is correlation, what is covariance, and what is population and what are samples. So based on our previous learnings, it will be easy for us to start this topic. So now I will give you the exact definition of statistics. But first, let's understand random variables. Random variables is something that we will be using frequently in our lessons, right? So it is important to understand what are random variables. Last time I gave you a brief idea about data, right? So there are two types of data normally. One is qualitative, another one is quantitative. Quantitative data again can be divided into two more categories. One is discrete and the other one is continuous. So random variables basically are quantitative data. Okay. So they are divided into two categories, as I mentioned, discrete and continuous. Continuous or numerical. So discrete variables. So what are these actually? These are isolated values within a given range. These are isolated values within a given range. Basically, they are whole numbers. So for example, let's say number of children you have, right? So out of 10, you may have 3. In a given range of 10, you may have 3 or 5 or 2. So this is an example of discrete random variable. One more example may be number of family members in your family. Number of family members in your family. This is again a whole number. One more example may be, let's say, number of bank accounts you are having. This is again a whole number. So these are the examples of discrete random variables. Discrete random variables. Now, what are continuous random variables? These are any values within a given range. Within a given range. Just don't blame me, guys. I have a very bad handwriting, but I'm trying my best to make it readable. So continuous random variables are any values within a given range. So they can be integers and can be float. That's why I said any values. What are the examples? Examples may be height of a person. Height of a person. This can be an example of continuous random variable. So height of a person can be 5.6, 6.2, 4.5, any numbers, right? One more example can be weight of a person. This is also one example of continuous random variables. Now weight can be 75 kilos, can be 60 kilos, can be 85.4 kilos, right? It can be integers, it can be float, right? So these are the examples of continuous random variables. So now we know that when I speak of a random variables, it basically They can be discrete or they can be continuous. Okay, so randomly these values maybe are generated something, but this basically follow in these two categories. And it is nothing but quantitative data. So now let's study statistics. We see the definition of statistics. Let me go to the next screen. So, sorry, give me a moment. Yeah, statistics. So last tutorial, guys, I have said that to understand statistics, you need to know few terms like mean, median, mode, samples, what is the population and all that. Now this will be helpful to understand the definition of statistics. So statistics is a science that concerns or that concerns with, it deals with the data. First of all, statistics deals with data. Okay, it concerns about collecting the data. Data can be anywhere. Data can be in a file system. Data can be in the servers. So it's all about collecting the data, organizing the data, organizing the data. Organizing the data means you want to organize it in a particular format in which you can study them, right? Organizing the data, analyzing the data, interpreting the data. What's the data all about? Right? What is present in the data? What is the flow of the data? Okay, what's it's telling us? So we will interpret the data, and finally presenting the data. This is all about statistics. Okay, now we divide statistics into two categories. So statistics is divided into two categories. One is descriptive statistics. Descriptive statistics. And the other one is inferential statistics. Inferential statistics. So what is this descriptive statistics? Descriptive statistics deals with describing the data. Describing the data that we have in hand. Now, what do you mean by describing the data? So we study the data basically. We try to find out information from the data. We do it by measure of central tendency. We try to find out what is the average. We try to find out the spread of the data, by measure of dispersion using standard deviation or variance. We find out the correlation in the data. Correlation in the sense, there will be input and output features, right? So what is the relation between input and output features? Which input features are important for predicting an output, right? So it's very important to know that. Also, correlation within input features. This is also important. Maybe out of 5 features, only 2 are important. The rest of the 3 are correlated with each other. So we'll discard those 3 features in model building. We'll not consider them. Simply because it will increase our computation, and unnecessarily it may impact our model's accuracy. Impact model accuracy. So we'll not consider them. So these things are very important. So this comes under descriptive statistics. So once we do our descriptive statistics, we are very much sure about the data, because we will also do analysis Now, how we do analysis? We do EDA. What is EDA? EDA is exploratory data analysis. Exploratory data analysis. This is very important terms in data science. And everywhere you will see me using this particular thing, because before model building, we need to do EDA on the data. We need to explore our data with the help of tables, with the help of charts, with the help of plots. We'll plot the data, we'll see the distribution of the data, how the data is distributed, right? We'll perform all these things, and then only we know entirely about our data. That's descriptive statistics. We are describing the data, we are gathering information from the data, we are performing various plots, graphs, exploring the data in terms of them, and collecting the information. We are also finding the correlation if there is any. Finally, we know exactly what data we're dealing with. That's descriptive statistics. Now, the other one is inferential statistics. Inferential statistics basically, and this particular statistics, guys, descriptive, this does not give you any conclusion. Does not give us any conclusion. We cannot conclude anything from this data, right? We cannot draw inference from this data. We're just understanding what the data is. Conclusions are referred or done with the help of inferential statistics. Yeah. So let me rub a few portion, guys. Just give me 1 minute. So in inferential statistics, basically we draw out conclusion of a population from a population. Okay. Now you see, well, now you know what exactly is a population, right? So you know what is a population, you know what is samples are. So in inferential statistics, we try to find out conclusion about a particular population. How we do that? How we do that? How you can draw a conclusion from a population. Last time I discussed this, right? Let's say you want to know the average height of a particular city, right, in a particular state. Now, how you will do that? You will not go to each and every individual houses and collect their height information, right? That will be tedious and that's not a smart move. So rather than that, you will collect samples from the population of some size, let's say n, and based on this sample, you will find out the conclusion about the population. Now, conclusion about the population, that will again depend on the number of samples you are collecting, right? So whatever, let's say in this example, whatever is the average height of the population, we can get it from samples if we have a right amount of size of the sample, right? Because we know that average of samples will tend towards the population's average if we increase our size, that I've discussed in my last discussion, right? So this is all about inferential statistics. How we do that? We do that with the help of various testings. There are lots of testings that is involved in inferential statistics. There is z-score, there is t-test, there is chi-square test. All these things we'll discuss one by one in our discussions later. There is ANOVA test. This test basically helps us to conclude about a certain population. Okay, if you want to know something about the population, we can know that. And all these testing basically are named as hypothesis testing. Hypothesis testing. Meaning we have a theory and we want to prove that our theory is wrong or right. This is just a basic idea about hypothesis testing. I will come to this also in my later classes. But for now, just remember that we will have a theory and we want to prove that our theory is wrong or right about a particular population. This is nothing but we are concluding about certain things about the population that comes under inferential statistics. So this is all about statistics, guys. It's collecting the data, organizing the data, analyzing the data, interpreting it, and presenting it. Okay. It will be of two types: descriptive, inferential. Descriptive is all about understanding the data. We will not draw any conclusion from it. Whereas in inferential statistics, we draw conclusion. We take out the sample from the population, we study the sample, and then if our and based on our samples prediction, we try to predict what will be the result for the population. This is about statistics. So now that we have covered two things here, random variables and statistics. Now let's understand what is Gaussian or normal distribution. Let me take a new page. What is Gaussian or normal distribution? So guys, now we are studying the distribution of the data. Distribution of the data means how the data looks like when we plot it. Okay, how the data will look. So that's distribution. So we want to understand the distribution of the data. For that, we need to refer somewhere, right? So Gaussian distribution, basically, it's an ideal distribution. You will not find any distribution of data in the modern world which will exactly match our Gaussian distribution. It's basically on theory. Most of them will be approximately similar to normal distribution, but not exact, approx. Okay, so let's understand what exactly is a Gaussian distribution or a normal distribution. So Gaussian distribution basically is a distribution of, let's say, a variable x. Okay, and its shape, its pattern is like a bell curve. So if you want me to draw, I can draw it for you. Let's say this is a graph, and this is a Gaussian distribution. Where what is the property for Gaussian distribution? Where the peak, this is the peak, right? Where the peak, in the peak we have mean, median, and mode. Three of them collides, or rather we can say they are same. So this is the average. So any distribution is a normal distribution or Gaussian distribution where, you know, at the peak we'll have this mean, median, mode all equal, and we have a symmetry on either side. We have a symmetry. So these are all the properties of a Gaussian distribution. Symmetry on either side. What do you mean by symmetry on either side? Means if you divide this curve in the half, right at the center, this particular portion and this particular portions are equally distributed. So we have a symmetry on either side of the curve. That's about this is Gaussian distribution. One more important thing to notice is most of the data points, right? Most of the data points will be near the center, meaning near the average. Most of the data points, as you can see here, this portion of the data is near to this particular average, right? So what happens if most of the data is near to the average? We have discussed this also, right, in our last discussion. If maximum data points are centered around a median on average, then we can make easy predictions, and our predictions will be approximately same and based on that particular average. How? Let's say I take the example of salaries. Let's say the salaries are distributed between this range, okay, in a particular company. Now, if I take the average of these 5 values, that average will be lying somewhere around here. So if someone asks me, okay, what is the average salary? If I say somewhere around 13.5, then I can guess, and then I can know, okay, 13.5 is the average salary, meaning the range is, meaning that if I'm saying that 13.5, meaning that most of the people in the particular company is earning this, right? And it is also approximately same, like 12 is very near to 13. It's very near to 15. It's almost near to 10, right? So our average prediction will be accurate or approximately same. And that is the reason, if our points are near the center, most of the majority of the points, if they're in the center, then if we are taking the average, basically, all these points can be, all these points can be defined, or all these points can be referred by referring this average value. So that's one very important point in normal distribution. The most of the data points will be centered around the mean, median, or mode. Okay. And also, lastly, one of the final characteristics of this one is the area under this particular curve. This is a curve, right? So area under this curve is given in, if you want to measure, it's given like 1 unit, meaning 100%. So 100% of the data points will fall under this area. 100% of the data points will fall under this area. That's why we say it as 1. So area under the curve, area under this curve, if you measure, it will be 1 or 100%. So this is Gaussian distribution, guys. Now, one more formula, or there is something called as empirical formula. Empirical formula to define a Gaussian distribution. To define a Gaussian distribution or a normal distribution is that. So let me draw the curve again. Let's say this is axis. Okay, just assume this is a Gaussian distribution. Okay, a Gaussian distribution curve. So, and let's say this is the center. This is the mu. So we know, right, what is mu? This is the population mean. And we also know standard deviation. We have studied standard deviation. What is standard deviation? The spread of the data from the mean. Spread of the data from the mean is standard deviation. So mu is mean and sigma is standard deviation. Okay, so let's say this is sigma, this is second, and this is third. Similarly here, this is sigma and this is third. What actually I'm trying to say here? So sigma is nothing but standard deviation. So this is for one standard deviation. This is one standard deviation. This is second standard deviation. And this is third standard deviation. What actually they are? So it says that if you define the data points, let's say this is an area that I'm defining. So sigma, that is standard deviation, is nothing but spread of the data, right? So our empirical formula, it states that probability of data points lying in the range between mean and first standard deviation is 68%. This also I discussed. So 68% of the data points will fall under this area. Okay, so our empirical formula for Gaussian distribution defines that 68% of our data points will fall under one standard deviation and mean. Okay. The second thing is, so we can also write it in this way, probability, let me change the color. Probability of data points, right? So between this 68%. So probability of the data points falling under this particular area is 68%. The second principle, the second formula is probability of the area, probability of the data points falling under the area between first standard deviation and the second standard deviation, between mean and second standard deviation is 95%. So it means if you define this area, so it means 95% of the data will fall under this particular range. 95% of the data points will fall under mean and second standard deviation. Okay, and the last one is probability of the data points falling between the mean and the third standard deviation is 99.7%, meaning 99% of the data points, 99.7% of the data points will fall between this between mean and third standard deviation. So this is 99.7%. This one between mean and second standard deviation is 95%. Between mean and first standard deviation is 68%. Okay, and the remaining, they are considered as outliers. We do not bother about them. Why? Because majority of the data we have, right? Why we need to bother about them? We'll discard them. I will make you understand that as well. Okay, but for now, just remember what is the empirical formula. It is 68, 95, 99.7% formula. So someone if ask you, okay, what is the empirical formula for Gaussian distribution? You will say that in the empirical in Gaussian distribution, 68% of the data points will fall between its mean and first standard deviation, whereas 95% of the data points will fall between its mean and second standard deviation, and 99.7% of the data points will fall between its mean and third standard deviation. This is the empirical formula for Gaussian distribution. Nice. So this is all about standard. This is all about our Gaussian distribution. Okay. Now let's move on to what is standard normal distribution. Standard normal distribution. Okay, so any normal distribution, any Gaussian distribution can be converted. It can be converted. Any normal distribution can be converted to standard normal distribution. Distribution with the formula x minus mu divided by this, where Mu is the mean of the population, and this is the standard deviation of the population. So any normal distribution, any Gaussian distribution. So you see this one, any normal Gaussian distribution can be converted to standard normal distribution with the help of this formula. X, nothing but the data points. Okay, where its mean will be 0 and deviation will be 1. This is very important, guys. So any normal distribution which may have a different mean, which may have a different standard deviation, can be converted to standard normal distribution with this formula. And the standard normal distribution has a characteristics of mean being 0 and standard deviation 1. So it will be like this, where mean, this one will be 0, and this will be like 1, 2, 3, -1, -2, -3. Sorry, let me again do it properly. So let's say this is 1, this is 2, this is 3, and this is, let's say again, I do it. So this is -1, -2, and -3. Okay, these are nothing but standard deviations. Standard deviations. 1 standard deviation, 2 standard deviation, 3 standard deviation, and so on. This is on this side, this is on this side. So that's why I've written minus. Okay, so this is the characteristics of standard normal distribution. So if someone asks you, okay, what is standard normal distribution? You will say a normal distribution whose mean is 0 and standard deviation is 1 is standard normal distribution. And how we can convert any normal distribution to standard normal distribution? We convert it with this formula. Z is equal to X minus mu divided by standard deviation. Z is nothing but Z score. I will come to it later on. So any normal distribution can be converted. Let's say we have some values, let's say 3, 7, 6, 11, 12. And let's say this is particularly, if you plot them, it follows normal distribution. How we will convert it? We first of all calculate the mean of this particular 5 values. We will have some number, and then we use this formula. Okay, so formula, if you plug in, it will be like, let's say 3 minus this value. Let's say I give this value as X. So 3 minus X divided by, we calculated the standard deviation as Y. Let's 3 minus Y. So this will be some number, let's say X1. Again, for this 7, X normal. Again, for 7, it will be 7 minus X is the mean, Y is the standard deviation. It will give me some number X2. For 6, again 6 minus X by Y. X is the mean, Y is the standard deviation. It will give some number 3. So ultimately we'll get all these values. And when we plot this particular values, it will be of this shape, and this will be the whole thing, where its mean will be 0 and this will be the standard deviations. This is what actually is standard normal distribution. Now the question that you may ask is why we require standard normal distribution. We already have a normal distribution and it's working fine. So what's the urge of having standard normal distribution? Why we need it? So the answer to it is very simple. Okay, the first point is we want to know, let's say we want to know the area, how much area one particular point covers in a particular distribution. So to simplify, we use standard normal distribution, or to know the probability of the area of a particular observation. It covers. Let's say I want there is one value 50. Let's say there is some value here in the standard normal distribution. Let's say there is a value here as 50. I want to know how much area it covers. So basically it will cover this area, right? If I give a different color, it will cover this area, this portion. This entire portion will be covered. How you will measure it? What is the area? How you will do it? We cannot do it simply by this data points, and that is one of the reasons we convert it into standard normal distribution. So the area is like, and with the help of the Z, we will calculate it. Let's go. The second thing is, let's say we have different variables, different random variables, let's say X, Y, which are normally distributed, and we want to compare these two variables. So how one because this will be in different scale and this will be in different scale. Let's say this talks about weight and this talks about height. So height is in different scale. It will be in feet or inches. Scale will be in pounds or kgs. So how we will compare both variables? So we need to standardize them. We need to bring them down to one particular unit, okay? And then we can compare it. So that's how standardization is very important. Then only we can compare these two variables. If they are not in the same scale, we cannot compare them. We need to bring them down to the same scale. That is what is standardization. And so we do standardization. So that's why we have standard normal distribution. Okay, so standard normal distribution is given by this formula. Z is equal to X minus mu divided by sigma. Please remember this formula, guys. So now we have discussed about statistics, we discussed about Gaussian distribution, we discussed about empirical formula, we discussed about standard normal distribution, and we also have a little idea what is that score, right? That score is given by this formula, right? So with this, I will close this session and I will cover this too in the next tutorial. Okay, I guess right now you have quite a few ideas about what are random variables, what is statistics, what is normal distribution, what is the empirical formula, what is the difference between standard normal distribution and normal distribution, and something a little bit about Z-score, right? So thank you guys. Keep learning and keep shining. And if you like this video, please subscribe, and thank you.